Welcome back to the deep dive. Today, we're going to try and break down the operating system for innovation. It's called design thinking.
That's right.
And if you've ever wondered how these massive tech companies or even, nimble startups consistently create products that just work for people, this is pretty much the methodology they're all using.
It is. Design thinking, or DT, sounds complicated, but at its core, it's just a framework. It's a system that forces you to put the human being first before you even think about the tech solution.
So our mission today isn't just to, list the 6 steps. You can Google that.
Yeah.
We want to get into how these steps are actually used in tech and pull out the strategies that separate a cool idea from a product that actually defines a market.
Exactly. And it's important to know, we're going to talk about these 6 principles in order, but in the real world, it's not so linear. Companies jump back and forth all the time.
But you have to start somewhere.
You have to. And that start is always phase 1, understanding the human and their problem.
Which brings us right to the first and maybe most important principle, empathy.
Empathy is the absolute cornerstone. Because it's the thing that stops us from just building solutions based on our own assumptions.
So it's more than just a survey.
Oh, way more. It's about deep immersion. You're observing users in their own environment. You're talking to them. You're trying to really understand their frustrations and the whole context of their problems.
You're looking for the aha moments, right? The things they can't even tell you they need.
Precisely. In tech, this is basically the heart of user experience, or UX design. You create an app that feels intuitive because it's built around how people already think, not just what's easy to code.
You also see it in really good accessibility features, things like voice navigation or haptic feedback for people who are visually impaired.
Yeah, and let's really dig into a big example here. Think about Apple and the original iPhone.
Oh.
The wisdom back then was that you needed a stylus. Every PDA had a stylus for precision.
I remember those, tapping away at those tiny screens.
Exactly. But the empathy phase, watching people, revealed a huge pain point. Nobody wants to carry an extra little plastic stick.
Or lose it.
Or lose it. The real insight was that your finger, while it's not very precise, is always there. So the choice to ditch the stylus for a capacitive touchscreen was a massive design decision, but it came directly from empathy.
That's a great example. You're sacrificing a bit of technical precision for a massive gain in human convenience.
That's the trade-off.
So, okay, you've done the work. You have all this rich, messy human data. What's next? How do you make that useful?
That leads us straight into the second principle.
Define.
This is the synthesis step. You take all those observations, all those insights, and you boil them down into a single, focused, actionable problem statement.
So you go from something vague like, we need better delivery software,
to something super specific, like our driver needs a way to navigate last-minute construction detours without falling behind on a very tight delivery schedule.
That's a critical difference. It frames the problem. I see this in agile development with user stories. As a user, I want X so that I can achieve Y.
That's the formula.
But how do you know your definition is the right one? User feedback can be all over the place sometimes.
That is the challenge.
Yeah.
And it's where you have to start using data. Look at Google Maps.
Okay.
Initially, their definition of the problem was just find the shortest route. Simple.
A to B.
A to B. But after years of synthesizing user complaints and looking at their own data, the definition changed. It became about optimizing for time reliability, for ease of use.
Right. So now it warns you about slowdowns ahead. It tells you which lane to be in. It's reducing my stress, not just my mileage.
Yes. They redefined the problem based on a deeper understanding, and they keep redefining it. You can see the same thing with Tesla's autopilot features. Right. It's a constant redefinition of what safe autonomous driving even means, based on millions of miles of new data.
So the define stage is never really done.
Not really. It's the anchor for everything that comes next. If you get the definition wrong, it doesn't matter how brilliant your solution is, it'll fail.
Okay, that makes sense. So that's phase 1. Let's move to phase 2, generating and visualizing solutions. We have a clear problem. Now we need ideas.
A flood of ideas. This is the third principle. Ideation.
Brainstorming,
mind mapping, anything that generates a wide range of creative solutions. The single most important rule here is no judgment. Not yet.
That sounds harder than it looks, especially with a room full of engineers who know all the technical constraints.
It is. That's why you see things like hackathons or innovation sprints. They create a temporary safe space for creative chaos. You have to structurally separate the act of creating from the act of evaluating.
Is that where something like Google's famous 20% time came from?
That is the classic example. It wasn't just a fun perk. It was a mechanism for ideation outside of an employee's main judged role. And it gave us Gmail.
Right. Gmail solved a problem most of us hadn't even fully realized was solvable yet. This idea of never having to delete an email.
And this isn't just for software. Think about SpaceX brainstorming how to make rockets reusable. Those early ideas must have sounded like science fiction.
Absolutely.
But you have to put the wild idea on the whiteboard right next to the safe incremental one. You have to.
Okay, so ideation is the creative explosion. What's next? You have all these ideas, some brilliant, some crazy.
Now you have to make them real, or at least real enough to touch. That's the fourth principle, prototyping.
Making it tangible.
Quickly and cheaply. That's the key. This is about building a simple version of your solution so you can get it in front of people before you commit a ton of time and money.
So in the digital world, that's like wireframing, right? Using tools like Figma to create a basic layout of an app.
Exactly, a low-fidelity mock-up. And for physical products, you have rapid prototyping. 3D printing an early model of some new IoT device, for instance.
And on the really big, complex end of the scale, you have things like digital twins, right? Simulating an entire factory or a jet engine before you build it.
Yes, that's a very advanced form of prototyping. But even simple prototypes are incredibly powerful. Look at Airbnb.
What do they do?
When they were trying to refine their booking system, they didn't just start coding. They made simple paper prototypes and literally walked users through the process. Click here, then this screen appears.
Wow, old school.
Super old school. But they found huge usability problems before a single line of production code was written. It saved them a fortune.
That's smart. It feels like Tesla does this too, but with their whole manufacturing process. Each car that rolls off the line is a prototype for the next one.
It is a continuous, iterative prototyping of the car and the factory itself.
That speed is what lets you get to phase 3, learning and refining. So we have a prototype. Now we need to break it.
Or at least find out where it's weak. This is the fifth principle, testing.
And testing isn't about proving your idea was good.
No, it's about learning where you were wrong as quickly as possible. You're gathering real user feedback to check for functionality, usability, and desirability. Do people even want this?
So this is where A/B testing comes in. I always think of Facebook.
They are the masters of it.
Yeah.
They don't just launch a new feature. They'll test like 5 different versions of a button on millions of users to see which one gets more clicks. It's constant, relentless digital validation.
It's fascinating to contrast that with, say, physical systems like NASA. Their testing protocols for space missions must be on another level.
It's the absolute extreme of system validation.
Yep.
You test every single component, every line of code, every possible failure scenario, because you can't have a do-over in orbit.
Sure.
But the goal is the same, whether it's a like button or a rocket engine. You gather objective data before you go all in, and all that data you gather from testing feeds right into the final and most crucial principle.
Iteration.
Iteration,
Yeah.
the continuous cycle of refinement.
This one feels like the engine of modern tech. It's this idea that your product is never really finished.
It's never finished. Iteration is about committing to that idea. It means being flexible, adaptable, and constantly refining the solution based on what you learned in the testing phase.
This is also where design thinking seems to just merge completely with modern software development.
It does. Iteration is agile development, essentially.
Yeah.
You work in these short cycles or sprints, and each sprint is like a mini DT process. You prototype, you test, you refine.
And this is what drives things like CI/CD pipelines, right? Continuous integration, continuous delivery.
Exactly. You're not waiting a year for the next big software release. You're pushing small improvements, sometimes every single day, based on this iterative loop.
Think about an app like Spotify. Their recommendation algorithm isn't static.
Not at all.
It's iterating constantly. It's learning from what I listen to, what I skip.
Right.
It's redefining what it thinks I want to hear next in real time.
That's a perfect example. And it's what drives the product evolution at Apple and Google, too. Their operating systems are basically these massive, perpetual, iterative projects.
Wow, okay, that's a lot of ground we just covered. So let's just quickly recap. We have empathy, then define.
And ideation and prototyping.
And finally, testing and iteration. It's really a whole mindset, not just a checklist.
It is. And the key takeaway for you listening is that this gives you a structured way to deal with ambiguity. It's a roadmap to go from a fuzzy problem to a validated, user-focused solution. And you can apply it to anything.
And for anyone who wants to go deeper on this, there are some really foundational books.
Oh, absolutely. Change by Design by Tim Brown is sort of the Bible of the field. And The Design of Everyday Things by Don Norman is essential for understanding the human side of it all.
Great recommendations.
And I'd also say, just go look at IDEO's website. They have case studies on everything from banking to healthcare. And the Stanford D School has a ton of free materials online that can help you actually put this into practice.
Fantastic. So we've talked a lot about how the whole tech world runs on this engine of iteration, of continuous refinement, which leaves me with a final thought for you to chew on. If companies like Apple and Google are constantly evolving their products, pushing updates, making tiny changes, what does the word finished even mean anymore in technology?
That's a great question.
Is a product ever truly complete? Or is it just resting between updates, perpetually in a state of being tested and prototyped?
I think finished might be an obsolete concept now. Maybe it's been replaced by optimized for right now. It's a moving target, which I suppose is what keeps things interesting.